Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today I am going to discuss about non-exact differential equations and how to solve that non-exact differential equations by using method 4. And in this method 4, what is the procedure we are going to follow to solve non-exact differential equations? We are going to see now. First of all, what is a non-exact differential equation? Already we discussed in the previous videos in the method 1, 2, 3. Just once I want to recall you. So here, if the differential equation m of x comma y into dx plus n of x comma y into dy equal to 0 be not an exact differential equation, when we can say that this is not an exact differential equation, m dx plus n dy equal to 0 can be made exact by suitable function u of x comma y not equal to 0. That means we should multiply with some function to convert this equation into exact equation. That means here dou m by dou y is not equal to dou n by dou x. Then we can say that this equation is not exact differential equation. So how we can convert this equation into exact? So that means here dou m by dou y equal to dou n by dou x. How we can convert this not equal into equal means we are going to multiply with some suitable function. What is that suitable function? So based on the methods we are having different integrating factors. So based on the procedure and based on the equation we are dividing here to solve the not exact differential equation by using the integrating factor. So what is the integrating factor? For this method 4, we are going to see here. First in the method 4, how the equation will be and how we can identify to apply this method 4. We can observe here, if there exists a continuous single variable function f of x. If there exists continuous single variable function f of x such that here dou m by dou y minus dou n by dou x by n value that should be equal to f of x. Nothing but here f of x is in terms of x. If this value equal to f of x, then we can say that integrating factor is e power integral f of x dx. This is the integrating factor if you satisfy this condition. So how we can choose method 4? First, alternatively we have to check about the method 1. That means there is any possibility to grouping the terms for the equation or not, we are going to see. That means the first method is grouping the terms, right? So we have to check that one first. After then, in the second method, what we are following in the second method? So 1 by mx plus ny. So this will be here mx plus ny not equal to 0. Then mx plus ny, 1 by mx plus ny is the integrating factor. In the next method, third method, mx minus ny not equal to 0. Then integrating factor is 1 by mx minus ny. And here one condition is there, the equation should be homogeneous. Here the condition is y into f of x comma y into dx plus x into g of x comma y into dy equal to 0. So based on this equation we are going to decide about method. Which method is we are going to see here. So first, after checking these 3 methods, if 3 methods are not possible, we are moving for the fourth method. What is the fourth method? The fourth method, here there exists a continuous single variable function f of x. That means f of x is the continuous single variable function. That means only we should have single variable. So how we can say that? That is dou m by dou y minus dou n by dou x by n should be equal to f of x. This is the single variable function. That means we are having the function in terms of x only. Then only we can apply this method 4. So how we can solve and how we can apply the method 4, we are going to see now by using the example. See here, solve 3xy minus 2ay square into dx plus x square minus 2axy into dy equal to 0. This is the given equation. So here solve 3xy minus 2ay square into dx plus x square minus 2axy into dy is equal to 0. So this is the given equation. We are going to solve this equation now. So here, first of all, what is the m value, what is the n value, we are going to identify. So m value is here, this is in the form of m dx plus n dy equal to 0. So this is m value. What is the m? 3xy minus 2ay square. What is the n value? X square minus 2axy. So here what is the procedure we are following? First we are going to check about dou m by dou y value. So here dou n by dou x value. After then we will decide about the equation, is it exact or not exact. So here dou m by dou y means we are going to do the partial differentiation of m with respect to y. So here with respect to y we are doing means 3 also constant, x also constant, y derivative is 1 minus 2 also constant, a also constant, y square derivative is 2y. So 3x minus 4ay, 3x minus 4ay. So here dou n by dou x value, that means we are doing partial differentiation of n with respect to x. So x square derivative is 2x minus 2 and a and y, 3 are constants. That means we are having here 3 values. I mean with respect to x we are doing y also constant, 2 and a both are constants. So x derivative is 1. So 2x minus 2ay, 2x minus 2ay. Here we got dou m by dou y value is 3x minus 4ay. Dou n by dou x value is 2x minus 2ay. So dou m by dou y is not equal to dou n by dou x. Dou m by dou y is not equal to dou n by dou x. So if this condition is not equal, means this is a non-exact differential equation. This is non-exact differential equation. So now we are going to check about the first conditions, sorry, my first method, second method, third method, after that fourth method. What is the first method? Grouping the terms. If there is any possibility to grouping the terms in this equation, so not possible. Next, second one is, here there should be a homogeneous equation. Here x square is there, here x is there. So like that, this is not a homogeneous equation. This is not a homogeneous equation. So we are not following the second method. For the third method also, there should be y into f of x comma y dx plus x into g of x comma y into dy equal to 0. So if this form is having, then we can go for the third method. Here in this equation there is no other form. That means third method also not following. So here we are going to check about the fourth method. So that means we are going to check about dou m by dou y minus dou n by dou x by n value. We should get only single variable continuous function, that is in terms of x. Then only we can apply the fourth method. We are going to see here about this value, is it single variable or not. So here dou m by dou y value is 3x minus 4ay and dou n by dou x value is 2x minus 2ay. So here dou m by dou y minus dou n by dou x. What is the dou m by dou y value? 3x minus 4ay. 3x minus 4ay minus of dou n by dou x value. So here 2x plus into minus minus. So minus 2x minus of minus plus 4ay. So by n value. What is the n value here? 2x minus 2ay. 2x minus 2ay. So here 3x minus 2x is x. Here plus 4ay minus 4ay will be cancelled. So here this value we are writing here. This is 2ay. So here 2ay. So x minus, here 3x minus 2x is there. So x minus 2ay we are having. X minus 4ay plus 2ay. So plus 4, minus 4 plus 2 is minus 2ay. By here we are taking the x common. X minus 2ay. X minus 2ay. So now this will be cancelled. This will be cancelled. So finally I will get 1 by x. This is the only single variable function. That means we are not getting any other variables. We are having only x. Otherwise, if we are having only y, that method will be different. We are going for fifth method. We will discuss it later. So here we got 1 by x. That means we got only single continuous variable function. So this condition is satisfied. That means we can follow the fourth method. So f of x value is 1 by x. F of x value is 1 by x. If dou m by dou y minus dou n by dou x by n value is 1 by x, what is the integrating factor? Integrating factor is e power integral p of x or f of x dx. What is the f of x value? E power integral 1 by x dx. So e power integral 1 by x dx is log x. E power log x, here x into log e base e, so value is x. That means integrating factor I got x. So here integrating factor is x. We can see here in the same way. So e power integral 1 by x dx. So that is equal to x. This is the integrating factor. So what is the use of the integrating factor? Here we are going to convert non-exact differential equation into exact differential equation by multiplying with integrating factor. That's why we calculated the integrating factor here. So here integrating factor is x. We are going to multiply with the given m value and n value. So m dx 3xy minus 2ay square into x. Here dxy minus 2ay square into x into dx plus x square minus 2axy into x dy equal to 0. That means here we got new m1 and new n1 values. So what is the m1 value here? I am going to multiply this one with x. So 3xy into x is 3x square y. 3x square y. So here minus 2ay square into x is minus 2axy square. This is the x value. Now what is the, this is n1 value. What is the n1 value? So n1 value also x square into x is x cube minus 2axy into x is 2ax square y. So now here you should get dou m by dou y is equal to dou n by dou x. So that is the meaning of the integrating factor. So we are converting non-exact equation, differential equation into exact differential equation. So here dou m1 by dou y. So here with respect to y, we are doing, so 3 and x square both are constant, y value is 1 minus 2ay, 3 values are constant, so x derivative is 1. Finally this value is 3x square minus 2ay, 3x square minus 2ay. This is the value of dou m1 by dou y. So here dou n1 by dou x now. So with respect to x we are doing x cube derivative is 3x square minus 2ay. 2ay. These are the constants here. So x derivative is 1. X derivative is 1 here. So now finally 2a dou m by dou y minus dou n1 by dou x both are equal now. So that means this is the exact differential equation. This is the exact differential equation. So we can observe here m1 value is 3x square y minus 2ay square x and n1 value is x cube minus 2x square y. Dou m1 by dou y. Here 3x square y derivative is 1. So and here 2a and x also both are constant. So y square derivative is 2y. Y square derivative is 2y here. And so finally this is 3x square minus 4a. 3x square minus 4axy. So here also into 2x. So finally 3x square minus 4axy. 3x square minus 4axy. So here y square is there, here x square is there. So that's why we got here 3x square minus 4axy, and here also 3x square minus 4axy. We got the both values are equal. That means this is the exact differential equation. So after getting the exact differential equation, the procedure is as it is. We can calculate the general solution. What is the general solution? General solution equal to integral m1 dx plus integral m1 dy equal to c. So integral m1 dx plus integral n1 dy equal to c. What is the m1 value? So m1 value is 3x square y minus 2ay square x into dx. This is m1 value integral. What is the n1 value? So n1 value already we observed here. N1 value is x cube minus 2ax square y. N1 value is x cube minus 2ax square y. Here there is no possibility to separate the only y term. So here for the n we are going to take 3 from x. That means we are going to take only y terms. Only y terms, right? So here there is no possibility to separate the y term for the n1. If there is a possibility to separate the y term, then we will take only y term for the n1 value. So here there is no possibility. That's why we are taking 0. So 0 into dy equal to c. So finally here when you are doing with respect to x, 3 is the constant, y is the constant, integral x square dx minus 2a also constant, y square also constant, integral x dx plus here 0 equal to c. So 3y. So integral x square is x cube by 3 minus 2a y square into integral x is x square by 2 equal to c. So finally we are calculating here 3 will be cancelled, x cube y here 2 will be cancelled minus a x square y square equal to c. This is the general solution. This is the general solution of given exact differential equation. So for the non-exact, we are going to convert into exact differential equation by using the integrating factor which is suitable to that equation. To get the better clarity about this method, we are moving for one more example. We can see here, solve y dx minus x dy plus 1 plus x square into dx plus x square sin y into dy equal to 0. What is the given equation? We are going to write here by dx and here for the dx 1 plus x square. So we are taking these two. So y plus 1 plus x square into dx and here x dy is there. Here x square sin y. So x square sin y minus x dy. X square sin y minus x dy. This is the dy term multiple and this is the dx multiple. That means this is in the form of m dx plus n dy equal to 0. So from this we are going to write m value. What is the m value? M value is y plus 1 plus x square. And what is the n value? N value is x square sin y minus x square sin y minus x. Now same procedure what we followed in the previous problem. First we are going to check about dou m by dou y. So dou m by dou y equal with respect to y we are doing. So y derivative is 1 plus 1 is constant 0 and x square also constant 0. So here dou m by dou y value we got 1. That is only we got here. Next coming to dou n by dou x. Dou n by dou x. With respect to x we are doing here sin y is the constant. Derivative of x square is 2x. Derivative of x square is 2x minus x derivative is 1. So finally this is 2x sin y minus 1. So here clearly we can say that dou m by dou y is not equal to dou n by dou x. Dou n by dou y is not equal to dou n by dou x. That means this is the not exact differential equation. So here what is the procedure we are going to follow for the equation? We are going to follow this equation by using the method 4. So what is the method 4? For the method 4 we are going to calculate dou m by dou y minus dou n by dou x value divided by n. This should be single variable function. That should be in terms of x. So that value we are going to calculate now. See here, dou m by dou y minus dou n by dou x. So what is the dou m by dou y value? 1 minus dou n by dou x value is 2x sin y minus 1 by by n. What is the n value? X square sin y minus x. So here when you simplify this equation, 1 minus 2x sin y plus 1. Here minus of minus plus. So this will be my, we are taking the x common here, sin y, x sin y minus 1. So here we are getting 2 minus 2x sin y by x into sin y into x minus 1. So when you are taking the common here 2, we are taking the common minus 2 here. So 1. So taking the minus 2 common, we are getting x sin y minus 1 divided by here x into x sin y minus 1. So x and y minus 1, x and y minus 1 will be cancelled. Finally, we got minus 2 by x. That is only we wrote here. So we can observe the simplification here. 1 minus 2x sin y plus 1 by x square sin y minus x. Here we are taking the x common here. So x sin y minus 1. Here minus 2x sin y plus 2. Taking the minus 2 common, these 2 will be cancelled. Finally, we got minus 2 by x. This is the f of x. So that is nothing but single variable function. So integrating factor is e power integral f of x dx. So e power integral minus 2 is the constant, integral 1 by x dx. You can observe here e power minus 2 is the constant, 1 by x dx. So e power minus 2, integral 1 by x dx is log x. So now we are taking e power log x power minus 2. So log e base e, finally this value is x power minus 2, nothing but 1 by x square, 1 by x square. This is the integrating factor. So why we are calculating the integrating factor? To multiply this one with the equation to convert into exact differential equation. See here, we are multiplying the given equation with the integrating factor. So what is the given equation? M value, that is y plus 1 plus x square into dx plus x square sin y minus x into dy equal to 0. So we are going to multiply this one with the 1 by x square. So we can observe here 1 by x square is there. So y plus 1 plus x square by 1 by x square into dx plus x square sin y minus x by x square into dy equal to 0. So now we got m1 and n1. So these are the new m1, new m and new m value. So what is the new m1 value? Y plus 1 plus x square by x square. And what about the n1 value? X square sin y minus x by x square. So now we are going to calculate dou m1 by dou y value. With respect to y we are doing, x is the constant. So here 1 by x square is the constant and y derivative is 1. Plus 1 is the constant and x square also constant, 0. So finally we got 1 by x square. And in the same way we are going to calculate about dou n1 by dou x here. So with respect to x we are doing. So here x square by sin y and x square will be cancelled. So sin y is the constant, this value is 0. We can simplify here. So this is n1 equal to first x square sin y by x square minus x by x square. So x square will be cancelled, x will be cancelled. This is sin y minus 1 by x. This is sin y minus 1 by x. So now we are going to calculate dou n1 by dou x. So what is the here? Sin y is the constant, so 0 minus here 1 by x is minus 1 by x square. Finally this is 1 by x square. So finally dou m1 by dou y is equal to dou n1 by dou x. So now we got this is the exact differential equation. If it is exact differential equation, we can follow the procedure to calculate the general solution. What is the general solution here? Integral m1 dx plus integral n1 dy equal to c. What is the m1 value here? m1 is integral y by x square plus 1 by x square plus 1 into dx plus integral n1 value. What is the n1 value? X square sine y. Here sine y minus 1 by x. So we can separate the y term here. That's why we are taking n1 as sine y into dy equal to c. Sine y into dy equal to c here. So now integral. We are going to integrate the function now. So y is the constant taking out. Integral 1 by x square. Integral 1 by x square dx plus here also integral 1 by x square dx plus integral dx plus integral sine y dy equal to c. So what is the integral 1 by dx? 1 by x square is minus 1 by x. Here also 1 by x square is minus 1 by x plus integral dx is x plus integral sine. Integral sine is minus cos equal to c. So finally this value is minus y by x minus 1 by x plus x minus cos y equal to c. So we are multiplying here with x. So minus y minus x plus x square minus x cos y equal to c. So this is our general solution. So this is the procedure to solve the given non-exact differential equation by using the method 4. I hope you get better clarity about the method 4 in the non-exact differential equation. If you want more problems and more examples, we can observe and we can refer these textbooks. So here, Higher Engineering Mathematics written by V.S. Gravel and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Engineering Mathematics written by B.V. Ramana, and one more textbook also is there, Engineering Mathematics written by T.K.V. Iyer. This is Eastern Publications. You can refer all these textbooks to get the more examples and to get the practice. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.